Intermediate Algebra for Statistics, using the square root property to solve quadratic equations. Lesson objective: use the square root property to solve quadratic equations. Lesson objective: solving quadratic equations of the form x squared equals k, where k is greater than or equal to 0. Property: let k be a non-negative constant. That's another way of saying a positive number or 0. Then x squared equals k is equivalent to x equals plus or minus the square root of k. So when we have an x squared and we want to get the x by itself, to undo the square, we take the square root. Now what we have to remember is there will be two solutions, a positive and a negative, and that's what this symbol here means, plus or minus. So why do we have two solutions? Well, let's take the first one, positive square root of k. If I take positive square root of k and substitute it back in the original equation, I want to see, does the left hand side equal the right hand side? So I substitute square root of k in for x, I square it, and square root of k times square root of k is k. So the left hand side equals the right hand side. Now if I do the same thing for negative square root of k, I get negative square root of k times negative square root of k. Negative times negative is positive, and we have k equals k. So if the equation is in this form, you are likely to have two solutions. The only time that you'll have one solution is if k is equal to 0. Let's do an example. Example 1. Solve x squared equals 16. Number 2. Solve x squared equals 45. Solution. Number 1. We want to get the x by itself, so we take the square root of both sides, and using the previous property, we have x equals plus or minus the square root of 16. And this is known as the square root property. Now the square root of 16 is a positive 4, so we have x equals plus or minus 4. So there's two solutions for this equation. Positive 4 will work, and negative 4 will work. Number 2. X squared equals 45. We take the square root of both sides, and using the square root property, we have x is equal to plus or minus the square root of 45. Now if you recall, there is a perfect square in 45, and that's 9, so we can split it up to x equals plus or minus the square root of 9, which is 3, times the square root of 5. So these are our two numbers that will make this equation true. To check it, we can take negative 3 radical 5 and approximate it using the calculator, and we get negative 6.71 to 2 decimal places, and positive 3 radical 5 is approximately positive 6.71 to 2 decimal places. So if we put x squared in y1 and 45 in y2, so left hand side of the equation in y1, right hand side in y2, and we want to look and see where these two intersect. So using the intersection feature, we see the first one is at a negative 6.71 approximately, and the second intersection is a positive 6.71. So we have verified the answer using the graphing calculator. Example 2. Solve 3x squared minus 5 equals 6. So we need to get rid of the square, we need to get rid of the 3, and we need to get rid of the 5. Solution. Our first step is to add 5 to both sides. Next, we want to get rid of the 3, so we divide both sides by 3. So now we have x squared equals 11/3. To get rid of the square, we take the square root and use the square root property. So we have x equals plus or minus the square root of 11/3. Next, we want to use the quotient property to split the square roots. So we have x equals plus or minus the square root of 11 divided by square root of 3. Now we need to rationalize the denominator, so we're going to multiply this fraction by square root of 3 over square root of 3, and we get our final answer plus or minus the square root of 33 divided by whole number 3. Solving quadratic equations in the form px plus q quantity squared equals k. Example 3. Solve 3w minus 4 quantity squared equals 36. Solution. We need to get rid of the 3, the 4, and the square. In this case, we need to get rid of the square first. So we take the square root of both sides, and using the square root property, we see that 3w minus 4 equals plus or minus square root of 36. Square root of 36 is 6, so we have 3w minus 4 plus or minus 6. So we have two different equations. 3w minus 4 equals 6, and 3w minus 4 equals negative 6. So we solve both of them. For this equation, we're going to add 4 to both sides, and we're going to add 4 to both sides here. And then we divide by 3 and divide by 3. And we have w equals negative 2/3 or w equals 10/3. These are two solutions for this equation. Example 4. We have negative 2x plus 10 squared equals 32. Solution. Our first step is to take the square root of both sides. Squaring and square root cancel, and we have negative 2x plus 10 equals plus or minus the square root of 32. Next, 32 has a perfect square, 16, so the square root of 16 times the square root of 2 gives me 32. Square root of 16 is 4. So we have negative 2x plus 10 equals plus or minus 4 radical 2. To get the x by itself, I need to get rid of the negative 2. I need to get rid of the 10. So we subtract 10 to both sides. Now we divide by negative 2. So next, can any of this simplify? Is negative 2 a factor for these two terms? The answer is yes. We can factor out a negative 2. That will make this a positive 5, and since this is plus or minus, it's not going to affect it. So 2 times 2 is 4. We factor out 1, 2, we have another 2 left. This negative 2 and this negative 2 cancel, and we are left with x equals 5 plus or minus 2 radical 2. To check the solutions, 5 plus or minus 2 radical 2 for the equation, we will check the first solution, x equals 5 minus 2 radical 2. We substitute 5 minus 2 radical 2 in for x into the equation. We multiply it by negative 2, and then we add positive 10, and then we square it. Now if this solution is correct, the left hand side will equal 32, because the right hand side is 32. Following the order of operation, we distribute the negative 2. Negative 2 times 5 is negative 10. Negative 2 times negative 2 radical 2 becomes a positive 4 radical 2 plus 10 quantity squared. Next, we can combine like terms. We have a positive 10, negative 10, they cancel. So we are left with 4 radical 2 squared equals 32. And 4 radical 2 times 4 radical 2 becomes 16 radical 4, and radical 4 is 2. 16 times 2 is 32, so it checks. For the second solution, x equals 5 plus 2 radical 2. We do the same thing as before. We substitute that in for x. Next we distribute the negative 2. Next we combine like terms, and we get negative 4 radical 2 squared equals 32. Negative 4 radical 2 times negative 4 radical 2 is a positive 16 radical 4, which becomes 32. So the left-hand side equals the right-hand side. It checks. Using a graphing calculator, we can approximate the two solutions. 5 plus 2 radical 2 is approximately 7.83, and 5 minus 2 radical 2 is approximately 2.17 to 2 decimal places. So for the first solution, typing in the expression on the left hand side of the equation, we see something very close to 32. It's not going to equal 32 exactly because we are approximating 5 minus 2 radical 2 to 2 decimal places. Doing this for the second solution, we see that it also checks. Thanks for watching.